Hello, everyone. Welcome to the next episode of the Hewlett-Packard Lab podcast, From Research to Reality. This time, I have a great honor and pleasure to host Ted Emerson. Hello, Ted.
Hey.
And Chandrasekhar Putilate. Hello, Chandrasekhar.
Dejan.
Or Sekhar, as you would prefer.
Yes.
This time, we're going to talk about ILO. And I will let Ted explain to you what does ILO mean.
ILO stands for the Integrated Lights Out ASIC. It was a dream at one point and became a reality right around the turn of the century. And we've been, not too many people know that we do our own management component, our own management chip. And so we're really proud of that. We're passionate about that component being as useful as it possibly can be, and solve real customer problems in the industry. And so
So will I have to change the name of the podcast from dream to reality as opposed to from research to reality?
I think you might. I think you might.
And it appears to me that you might have been that dreamer and researcher. Is that correct?
You know, I was super fortunate, Dejan. Who gets to have an idea and gets to see that idea developed, gets to see a company invest in that idea, gets to see that idea investment turned into a chip, and then gets to see that chip placed on every single one of our products? Who gets to do that? I mean, not every one of our products, just the important ones.
And Ted, we're all proud of you. But you did that dream research, and then you did the reality.
Yes.
So
Yes.
what's your role?
So I work for the ILO firmware. The most recent was the ILO 7 firmware, which went into the Gen 12 Pro lines. So what he talked about the ASIC side, on the firmware side, we have to add a lot of secret sauce to make this ASIC and the firmware as a one product, which is probably the best, out there.
And we love these guys.
Yeah.
Because these guys,
Yeah.
right? It's not a product unless you can marry that firmware and that hardware together. And that's really what's made ILO super successful. We're now about to release ILO 7, and we have a whole family of these, and it spans 2 decades. And why do we still do it? How are we able to still do it? Why are we still in this game? We're still in this game because of the strong partnership between hardware and firmware.
Exactly. Likewise. Yeah.
But tell me more, Chandrasekhar, why is ILO important? Why has it lived such a long time? Why is he so excited about you? Why are you so proud in making it real?
Yeah.
Why is that?
I think the key behind all of this is innovation. Over generations, to give you a background, and Ted can add more. I think this product is about 2 decades, more than 2 decades old, right? It's seen 6 generations in the field today, and every generation I see, and Ted has this whole suite of generations that he'll show you. Every generation has innovation built into it. And I think last 3 or 4 generations, security has been a huge differentiator in all of this. So that's what, I love working on this kind of stuff. And ILO 7, I think we'll talk about it more. I think this takes it to the next level.
But Ted, what does it do? What is ILO? You explain
Right.
what acronym stands for besides security.
Well, let me give you a little bit.
What would I do without ILO?
Let me give you a little bit of history on that. So I talked about a dream. I was not the first dreamer. Back in the 1990 timeframe, as Compaq, we did a product called the System Pro. And there were some talented folks that produced a card that plugged into that. That was sort of the concept of a server. They envisioned this management board that plugged into that server. Well, that management board did all kinds of cool things. It did kind of remote control, remote console. It did some monitoring, environmental monitoring. It even had a speech synthesizer.
Wow.
That could tell you that your server has got a problem.
20 years ago.
20 years ago. And so I guess my career has been spent getting that $1,000 board perfected to the point where we could put it on every machine and increase the manageability. My vision was the inherently manageable server, a server that just comes out of the box manageable. And so over the decades, we've introduced numerous technologies that help to support that vision.
And Chandrasekhar, one thing that I don't understand, why do you need another board? Why do you need another component? Couldn't just the simple computer do it itself? Wherever it's running application, you also run management. Why did you have to separate it?
So think of this way. I mean, if you have a new server in the data center, right? The unique aspect that ILO comes in is, today we tell some of the customers, all you need to do is plug the power cable and the LAN cable and then walk off the labs or the data center. Everything else that you can do, setting up the board, provisioning the board, installing operating systems, creating volumes, is all can be done through the BMC or ILO. If you were a traditional, PC without a controller like this, you cannot do any of this stuff remotely.
I was more interested in this in-band, out-of-band management. Why do you even need out-of-band?
So out-of-band gives you the ability to do things that you can't do in-band. In-band, in fact, that's where the name lights out comes from, right? When the power goes out in your house, you want the power to come back on, but what you need is a flashlight, right? So the lights out management solves those gaps where you can't use your in-band tools. When you're deploying a server, when you take it out of the box, there's no operating system on it. You can't use OS-based tools. And so, but ILO is there to the rescue. ILO comes up as an internet appliance inside your server. It already knows how to serve up web pages. You can already see your monitor and your keyboard and boot whatever media that you might have available to you. And so that's how we got started, was in the virtual presence technologies, the ability to remove any advantage of actually being physically there in front of the server. So that was the original vision, and as time has gone on, we've managed to adapt because the world catches up, and so we have to keep pushing the ball forward and keep reinventing ourselves, really.
And how does this pushing ball forward works? He comes up with a new version, you say, no, not good enough, give me another one. You pick it up, you say, I like this, goes into the product.
Yes. So it worked both ways. You're right. He comes up with the ASIC probably 3 or 4 years before it becomes a product. And he has a vision, which this is how, the ASIC and the hardware should look like, right? And at times, some of the features he envisions, the hardware capabilities he put in, simple things like the core count, the frequency and stuff like that. So that we say, hey, Ted, this is good enough for this generation. But there are some areas, hey, I wish it could be more better. So that's a constant feedback loop. So we give from the product back to Ted and team, the ASIC team in HPE, saying that, hey, how about you improve this, And the other feedback also sometimes we tell them is, we don't plan to use some of these capabilities, at some point because customers don't need it. Product management thinks, it's not needed anymore. So that feedback also, it's a constant loop that goes back and forth.
So based on what you two gentlemen just told me, it appears that's the most important component in any server. And there's huge responsibility.
Huge responsibility. Prime directive is do no harm. And we're passionate about that. We don't always succeed, Dejan, but we try.
That's what I was going to ask you about. Is there any interesting war story for us that you are willing to share, given the importance of the problem?
Oh, gosh. There are so many problems that come to mind, right? Problems that we ideally solve before the customer ever sees them. But we've learned a lot on this journey. Back in the days when we made the management cards, those cards were based on more of an off-the-shelf component, right? So it was a processor from vendor X, and we'll put it together on a board, and it'll do these things. But what we found is traditional chips like that are not designed with their DNA being for manageability. When you're doing manageability, you've got to expect that at any time the host could go away. In the middle of a cycle, it could go away. In the middle of a transaction, a bus transaction, you have to not break when that happens. And in the same way, when I talked about do no harm, the ILO itself might have to reboot for some reason.
Yeah.
There may be a firmware upgrade in progress,
Yes.
or some other event comes along,
Yeah.
and ILO
Yeah.
needs to reboot. When it does that, the host cannot go down.
Yep.
And so building this into the DNA of the chip, this whole idea of the separation between the host and the resilience between the host and the embedded subsystem is super important.
So how do you, I mean, this is frightening. How do you test it? I mean, you get from him, you have 4 years to test all the bugs, which could be
That's a fun
catastrophic.
question. So
There
Ted
are no
and team-
problems.
Yeah.
By the time it comes to him, there are
Yeah.
no problems.
So Ted
Is
and
that
team,
true?
No,
yeah.
it's not true.
to a large extent, so the reality is they do an excellent job of testing, simulating different types of, events, testing different IP blocks on the ASIC, right? And they have something called as, the Beast is one of the tools they use to test different parts of the ASIC. Now,
Built-in system test rather than.
No, it's
not-
It is
well,
beast in its own right.
it's a test operating system, and yeah, it's a test subsystem that we can run on it, and that was good that you brought that up, Sekhar. The other thing we do, and we're really proud of this, is every generation we build a fully functioning emulator. And we go and we buy the biggest, baddest chip that we can get out there. And some of these chips are very, very expensive, more expensive than my car. But with these chips, we can model the entire ASIC. And we can run his firmware
Yeah.
just like we would on the real chip.
on the production, yeah.
And so we can do a lot of the testing and the development in a real system, plugged into a real computer. And so this is tremendously powerful because we see the problems that you can't envision in simulation, right? The real world problems of booting an OS and this
Yeah.
and it shuts off the device in the middle as part of its bring up sequence. Oh, how are we going to respond to that? We didn't think about that. So these are the kind of things you see when you test on that emulator. So that emulator is super important.
Right.
Then when we get the actual chip, we build a second board that actually has pads down for the chip. So we go and we solder a part down, and then we take that firmware off of that emulator, and then we put it on that board, and it's a little bit like shooting off a rocket. You know pretty quick whether you're going to have a good day. And so,
Or a bad year.
or a bad year, yeah, because it's real expensive to make one of these chips. It takes a lot of design, a lot of effort, and I have to mention, Dejan, that the team that I work with is just amazing, right? And I've been super fortunate, blessed actually, to work with some of the best technologists that I don't know. They're just amazing people. Work so hard, they're so committed, and they've helped make this a reality. And I'm excited about your team now because I'm seeing the same kind of passion.
Yes.
That is part of the ILO DNA.
Right.
It's
So-
contagious, isn't it?
Yeah, so to continue what Ted's saying, when we get the ASIC rev for the firmware development, for the initial bring up so that we can develop some board support packages, the kernel and drivers and stuff. My experience has been the ASIC is already in a pretty good quality that we need, right? So what we do is now, for us, that's where the fun begins. ASIC is in a good shape. Now we got to do a lot of other fun. The platform has its own, instabilities, early boards and stuff. And ILO firmware, in this case, is at the center of the universe for all of those, right? For example, the host doesn't boot, ILO gets to blame for that. So we have to do now, take care of that, meet the performance expectations of end user. For example, the OS deployment that you said using virtual media. Then someone says, okay, I have to install this application, and ILO has to support some, management interfaces from the operating system. And lastly, it doesn't end there. It also has to now manage these many, many sensors on the board in the server. And the last icing on the cake is now ILO is to be managed and talk to the HPE cloud as well. So ILO firmware, while the ASIC is a very good, piece of hardware that we get, ILO firmware has to, scale from reading a tiny sensor on the board all the way to getting managed from the cloud. It talks to within the board, it talks to options, it talks to, the BIOS, the CPLDs, and, everything from firmwares to hardware to operating systems and applications.
It's almost like a supercomputer. I mean,
Yeah.
When I grew up, you did the bring up of these large systems. It's fascinating to me that you're doing bring up of the management processor with all this complexity.
Yes.
So tell me now, and let's start with you, Chandrasekhar. What is in plan next? You're going to release this version 7, is that right?
Yes. So version 7 is going to be, out in next few weeks from now. We are super excited. We have put a lot of new things on ILO 7. So things like, again, security is at the forefront of, all the new additions we have done. The second, theme that we are putting out there is the performance of the ILO 7 combined with the, the firmware plus ASIC enhancements we have. And the third one we have focused is on the usability. Sitting through some of these voice of the customer discussions is the UI, the user interface for ILO, we have always got feedback and we couldn't change that. So this time we have changed that. It's a completely, written from scratch kind of a UI. And I think, I'm hoping that a lot of end users will like that. So these are the 3 themes we are betting on.
Very nice. And while Chandrasekhar is busy releasing version 7, what's in plans for the future?
Oh, we have
To the extent you can share.
many dreams to dream yet. We always find ways to improve the product, right? So we've gone from a small 66 megahertz processor up to multi-core 64-bit in the latest. And, we have like 7 generations now of that chip. And we are very excited about the new one because that, I talked to you about reinventing ourselves. Architecturally, in Generation 10 servers, we introduced the whole root of trust security, the whole concept of making sure that every line of code that's run on this platform has been checked, has been validated. And so that was a huge success. We led the industry, as we have many times throughout ILO's lifetime. We realized that in this current generation, the one that's about to be released, that security was sort of that next big killer app. And so how do we grow up? How do we become not just the best management chip in the industry, but also the most secure? And so what we've done in this generation, and what I'm probably most proud of architecturally, is we've split the security plane and the management plane internally. And so there is a place for where security goes, and we've put barbed wire around it, and we've put barking dogs and things to try to keep intruders out. And that's not placed then on his shoulders that's having to deliver a management stack.
Yeah.
So the management stack that's running on the big processors then is free to concentrate on manageability and use the security plane as a resource. So that's really the big change. Other than just it's better, faster, stronger.
Yeah.
So
Chandrasekhar, I'm kind of guessing, but maybe not all audience will understand. What does it mean, root of trust?
Excellent. So when we get these, different firmware pieces, Ted talked about the security processor running its own firmware. Then on top of that, the management firmware and processor runs, right? And then on top of that, the BIOS operating system, right? Typically, industry talks about the secure boot, which starts from the BIOS and then option ROMs and operating systems and so on. Now, what we have in the ILO, the hardware, the ASIC itself is verifying the start of the whole security processor firmware that runs, and then the entire chain. The security processor verifies the ILO firmware verifies the BIOS. So all the way from the hardware up to the operating system is what the entire chain of trust is what it is.
Very nice. Can you explain to me, because we take pride in HP that we are force for good, so how is ILO contributed to the big contribution to the world?
Improve the world. That's a big thing to ask, Dejan. I think we've improved the life of system administrators. I think we've delighted some customers.
Enable all these computers to be more secure, manageable.
Exactly right. Thank you very much. Are you available to help the next chip architecture? Anyway, so yeah, exactly. And in the I got to go. I was fortunate. I got to go to HPE Discover in the summer. I got to escape the Houston heat to go to Las Vegas, which was even hotter.
Yeah.
That wasn't smart. Anyway, so at Discover, I met a gentleman that had named his dog ILO, and so when a customer names their dog ILO.
You must have done something
You
right.
must have done something good, as the musical would say.
And to add, one of the other things is, and Ted and me were talking about it a bit a few minutes ago before this. Sustainability is one theme that we are looking at, how to make this better. Today, if you see what we do is our power consumption is always at the top, right? It's a fixed power consumption. So there's some ideas, how can we, reduce the overall carbon footprint by reducing the power consumption. So we have to work on some of the details, but I think that's one of the force of good. We did a little bit of sustainability on the, upcoming ILO 7, but I think we can do more, and that's probably going to help.
That's good.
Yeah.
So today we are at the HP Techcom. Can you tell us, did you enjoy it?
This is a huge privilege, Dejan. It's a huge privilege to be here. I get to meet in person and talk to folks that I only get to talk to rarely. It's a unique experience, and it's really a privilege to be here. It's not a foregone thing, right? As a technologist, you have to keep inventing. You have to keep discovering. And construct these papers that are reviewed by your peers. And those ideas are vetted, and I don't get in every year. So it's a huge privilege to be here, and I'm trying to get every ounce that I can out of it.
Yeah.
How about you, Chandrasekhar?
Oh, same. Getting to meet all these bright people, who think on the same lines as we think. Doing all of this stuff, remotely will take probably days, weeks to, get to a conclusion and finding a solution. Here I can grab people to a room and say, hey, let's do this whiteboarding. This wouldn't have been possible. And of course, looking at the posters and presentations, I'm carrying back a lot of stuff, what to do into the roadmap.
Can you tell me a little bit about your career? Was it straight line, circles, up and down? How did it go?
I can start. Yeah, it's like, coming from, started with the telco domain, and then, started with software as the profession, that was the beginning of tech. And then did some RTOS, then came back to software. Then I went into the firmware, which is BMC. And after BMC, I don't think I have looked back in the last couple of years. So yeah, it's a kind of a jagged approach. It's not straight.
You, Ted?
So I started with Compaq right out of college, right out of the University of Illinois. And I went to that interview to go and explain to them how upset I was that the previous semester they didn't give me a plant trip. And so I ended up coming and visiting the Compaq campus, and I guess I've been here ever since. And it's, like I said, it's been a huge blessing. I've been able to do so many really interesting things, from my first project with the keyboard controller. So every keystroke every mouse movement that's been done in any Compaq or HP or HPE computer goes through that controller. That code I wrote back when I didn't know anything. And so it was later, after getting to do some code debugging with our processor partner, that I kind of got into the manageability. I saw that as an area of interest, and that's been a huge career. Now, a couple months away from my 38th anniversary here.
Nice.
They keep changing the name out front. It used to say Compaq, and then it said HP, and then it said HPE, but I just sit in my desk, do the same thing, and there you go.
Our audience likes to know a little bit about you personally. You spoke about your careers. You just mentioned you came out of Illinois, moved here.
Yep.
Is this either of places where you were born, or you were born in the third place? How are all these places different when you were born, when you grew up, studied, started working now?
So I grew up in a small rural community. I go to the university, and I end up in Houston. Very different climate, so I had to get used to that. But there's things to find that you love there too.
How about you, Chandrasekhar?
Oh, same. I was born and brought up in a small town, and I think those days were fun. Used to have a lot of friends, and I still do have all of them. Then moved to work to a different place, college education. Born and brought up in one place, education in a different place, and then so I've been traveling quite a bit, all within India. That's what I was doing.
Nice. And we end up with a book recommendation. Have you any book to recommend to our audience?
That presupposes that you've got time to read books.
Or listen.
I've been kept pretty busy with my lovely daughter, getting her through engineering school, and before that doing theater and photography, square dancing with my wife. So I've been pretty busy. But one book I did love to read, because I think it expresses that passion we have as engineers, by Gene Kranz, Failure is not an option. I love that book.
Nice.
Yeah, this is not a new one, but I just finished reading, a few months ago. This is called Sapiens by Yuval Noah Harari. It changed my view of, both the planet and the civilization, how it has evolved. And it has a very different perspective of, how to look at things. And of late, I'm reading some meditation books. Apart from that, I also read a lot of children books so that I can tell some stories to my kids. That's what I do. All right.
Hey, Ted, thank you very much
I enjoyed
for stopping by.
Hey, thank you, Dejan. It was a pleasure.